A standing wave is a type of sound wave that makes the pleasant notes we hear in instruments such as pianos and clarinets. Standing waves are the result of the interference between a wave and its reflection. What makes standing waves unique is that at a certain frequency, they appear to be standing still, as shown in this video.
Could it have an angle of reflection smaller than the angle of incidence?
3 wavelengths.
Wow.
Standing waves consist of nodes and antinodes. Nodes are any point on a standing wave that doesn't get displaced, while antinodes that are marked in green are any part of the wave that do. Standing waves must have the multiple of 1 or half a wavelength or they will not make a pleasant sound. It will be distorted. Here's one example of a standing wave. The part of the cord connected to the wall acts as a node, while the part I'm moving acts as another node, although I had to move it to actually make a wave. See how the cord appears to be still when really you see the waves mirroring each other. So what exactly is a harmonic? Basically, harmonics are the fundamental frequency and all the subsequent frequencies you get by multiplying the fundamental frequency by a whole number. So to understand what I just said, you're going to have to know what a fundamental frequency is. And a fundamental frequency is also known as the lowest resonant frequency because it has only 2 nodes at the end, and it's the lowest frequency that a note can have to be heard. So a fundamental frequency in a given string or chord is the frequency that a chord or note needs to vibrate at in order to create a standing wave. So the first harmonic is the fundamental frequency of a note or chord, and it has 2 notes and 1 antinode. And so this is half wavelength. And so that's the fundamental frequency. Okay, and this is the first harmonic. And then this is the second harmonic. It has 3 nodes right here, here, and here, and 2 antinodes. And this is 1 wavelength. And the second harmonic is twice the frequency of the fundamental frequency. So then the third harmonic has 4 nodes and 3 antinodes, and it is 3 times the frequency of the fundamental frequency. And this is 1.5 wavelengths. And then the fourth harmonic is 5 nodes. It has 5 nodes and 4 antinodes, and it is 4 times the frequency of the fundamental frequency. And this is 2 wavelengths. So the fundamental frequency determines like the pitch and like what you hear in a note. So again, harmonics are the frequency that a chord or note needs to vibrate at to create a standing wave. It's the lowest resonant frequency and the lowest you can go with hearing a note, or lowest frequency you can go with hearing a note. Harmonics are what give the sound of an instrument its characteristics or tone. So harmonics are what lets you differentiate the sound between a piano and a guitar. So when I pluck a string on my guitar, that's going to be half a wavelength, which is the first harmonic, right? Now, when you play notes, you hear the fundamental frequency of that note most prominently. Also, the frequency in the low E string is lower than the fundamental frequency of the high E string. So the lower fundamental frequency is going to be lower in pitch and sound lower to our ears than the high E string.